Now we'll go ahead and move on to unit conversions. Whenever we use units, hours, grams, and meters to measure quantities like time, mass, and distance, okay? But we can also use a variety of units to measure the same thing. Inches, centimeters, and miles are all measures of distance. We could use minutes, hours, and days to measure time. We can use pounds, grams, kilograms to measure weight. So unit conversion lets us change the units in which a measurement is given. Now on the SAT, you need to know the basic equivalencies for time and for metric units of mass, distance, and volume. So time, you need to know there's 60 seconds in a minute, there's 60 minutes in an hour, 24 hours in a day, 7 days in a week, 52 weeks in a year, 365 days in a year. You need to know those basic units for time. And then you need to be able to convert between metric units with those base values. Right? So for example, if we wanted to convert from grams to kilograms, we need to know that 1,000 grams equals 1 kilogram, okay? Or vice versa, that 1,000th of a kilogram equals 1 gram. You need to know those metric conversions. And there's a pretty easy way to look at it, and we'll take a look at that in just a minute. So to convert between the units, think of the conversion equivalency as a ratio, and we can multiply the initial measurement by that ratio to convert from one to the next. If you've ever taken chemistry, often stoichiometry or dimensional analysis is unit conversion, and so we can use a very similar model, which makes it much, much easier to quickly convert, especially if we have to convert multiple units within one ratio. It's important to remember that every unit besides the one you're looking for should only appear once in the numerator and once in the denominator. That way all other units can be canceled out. So let's take a look at converting 2,000 grams to kilograms. So within our metric, when we're looking at grams, when we're looking at liters, and when we are looking at meters, they all follow the same prefix. And so we have things like kilo and hecto, deca. Then we have what's called the base unit. Then we have deci, centi, and milli. Those are all the bases for each of the metric units. And so there's a little acronym to help kind of remember those. All right, and it's King Henry died by drinking chocolate milk. Okay, and that allows us to kind of remember, and actually let's do these lowercase because they are the smaller values, drinking chocolate milk. Okay, those are the beginning letters of each of the acronyms, and then whenever we're converting from one to another, we can just move along this line in a direction, and that tells us what that comparison between one value to the next is going to be. So let's look at how we're going to set this up. We're starting out with 2,000 grams. Okay? And then what we want to do is we want to end up at kilograms. All right? And so there's a long way and a short way, and we'll cover the long way first, and you can speed it up. But if we're converting from grams, which is our base unit, and we're going to the deca, well, it's a base 10 counting system. So there's 10 decagrams, there's in 1 decagram, there are 10 grams. And that pattern continues. When we go from deca to hecto, it is 1 hectogram is 10 decagrams. And then we go from hecto to kilo, 1 kilogram is 10 hectograms. And what you'll notice here, setting up these ratios, is that grams appears once in the numerator and denominator, decagrams appears once in the numerator and denominator, hectogram appears once, and we're left with kilograms. Well, when we divide a unit by itself, it cancels out, so all we're left with is kilograms. And so what we can do is just take everything in the numerator and multiply them together. 2,000 times 1 times 1 times 1 is 2,000, and then our ending unit, kilograms, divided by 10 times 10 times 10, which is 1,000, which gives us kilograms. So we can divide 2,000 by 1,000, and we get 2,000 kilograms. Now, the faster way to do this is you can note the conversion within across multiple units in the metric system. Okay, this works really well with the metric system, not so much with many others. But let's set up the same thing and say, okay, we're starting with 2,000 grams. Okay, well, in order to get 1 kilogram, we need 10 times 10 times 10 in order to get all the way to kilogram. And so we have 1,000 grams in a kilogram, and that just shortens up our multiplication a little bit. Now let's take a look at how many inches are in 1 yard. So because this isn't the basic metrics, they've given us the conversion. So we start with the 1 yard, and then we want to convert all the way down from our larger unit to our smaller unit. Well, they've given us this conversion that 1 yard is equivalent to 3 feet. So the yards have to be on opposite sides so they cancel. And then we'll continue from there. Feet needs to be on the bottom. 1 foot is 12 inches. So the feet cancel out again. And so then we just multiply 1 times 3 times 12, which equals 36. And then 1 times 1 is 1, 36 over 1. So it's 36 inches in 1 yard. How many seconds in 5 days? Same thing, we start with our 5 days, and because it's a basic measurement of time, we should know this conversion. So we start with days, and we want to think, okay, what's the next minute, what's the next value down? And that's going to be hours. So 1 day has 24 hours. And then what's the next unit down from hours? 1 hour contains 60 minutes. And then from minutes, 1 minute is 60 seconds. So we just multiply all the way across. 5 times 24 times 60 times 60. And we get a total of 432,000 seconds. Now, let's go ahead and convert units within rates. And so what we're going to notice here is that we have multiple conversions that we have to do. A white-tailed deer can run at a maximum of 30 miles per hour. What is the white-tailed deer's maximum speed in feet per minute? So we need to convert miles to feet and hours to minutes. And we can do this all in one-dimensional analysis conversion. So we'll start with our original, 30 miles per hour. Well, let's start with miles. Miles, they give us the conversion to feet, miles to feet. So we can write that in, that 1 mile equals 5,280 feet. So the miles cancels out and we're left with feet. We can also do the conversion from hours to minutes. Now, hours is already in the denominator, so we're going to go ahead and put 1 hour in the numerator, and 1 hour is 60 minutes. So we can cancel out this hour with that hour, and we're left with the desired unit of feet per minute. So we just multiply the numerator, 30 times 5,280 feet divided by 60 minutes, which gives us 2,640 feet per minute. The Kentucky Derby is a horse race over a distance of 10 furlongs. The fastest Derby winners complete the race in about 2 minutes. To the nearest tenth of a mile per hour, how fast must a horse run to complete the Derby in 2 minutes, given that 1 mile equals 8 furlongs? Okay, so we're trying to figure out if they need to go the distance of the Kentucky Derby, which is 10 furlongs, in 2 minutes. Now we need to do the conversion of the speed and miles per hour. So we need to convert furlongs to miles and minutes to hours. So let's go ahead and work through that. Let's do the furlongs to the mile because that's the first one given. 8 furlongs equals 1 mile. So we've got our unit of miles, which is what we need. And now we can convert minutes to hours. So there's 60 minutes in 1 hour. So our minutes cancels with minutes, and we can just go ahead and multiply our numerators and our denominators. So 10 times 60 over 2 times 8 gives us 600 over 16, which when rounded to the nearest tenth of a mile per hour, we're left with 37.5 per hour.